So as we said yesterday, the tough part here is being able to pick out the relevant pieces, kind of disassembling it, taking it apart and putting it back together as you need to. So here we're looking for the length BF. So here's B and here's F. How do we find that? Yeah, we're given that GB is 3. So GB here is 3. BF has to be just double that. That has to be 6 centimeters. So angle ADC. So here's A, D, and C. So this is angle ADC here. To find that angle, we have several choices actually, but one of the things, first thing I would think is if we knew this arc here, that angle, how is that angle related to that arc? Is it equal? It's either equal to it or it's half of it. It's half of it because it's inscribed. The vertex of the angle is on the circle. So to figure out that angle, if we knew that arc, so let's see what we can find out about that arc. Let's go here from what we're given. Let's put this all in. DC is 70 degrees. So DC, this is 70 degree arc. BA, that's this one, is 120 degrees. Which of course makes this piece here 60 degrees. How do I get that as 60? Yeah, BF is a diameter of the circle, so 180 minus 120 is 60. BKF, so BKF, that's this angle, is 30 degrees. What that tells me is that this one here is 150. How do I know that's 150? Because that's part of this quadrilateral formed with the two tangents. These two are right angles here and here, so these two have to be supplementary. So if this is 30, 180 minus 30 is 150 for that angle. So that tells me that's 150. We got, what's that? We're given that. GF and EA are perpendicular. I've already marked that as perpendicular right there. And EA is 5. So all the way across here is 5 centimeters. I'm not going to write that in right now because that's not relevant to any of our angles at the moment. So we're back to looking for angle ADC. Well, we know this is 70. This is 120. If we could find that piece, we'd be set. Do we have anything that will tell us angle or arc BC? Do I know this angle? 30. Because this is a diameter, the 50 to 150 and that angle form a straight line, so I have to add up to 180. So that's 30 degrees, making this a 30 degree arc.
Where'd you get 70?
The 70 here?
Yeah.
That's given.
Oh, okay.
So now I know that this highlighted arc here is 30 plus 120. So that's 150 degrees.
Where'd you get the 150?
The 150 here?
Yeah.
That's because this is 30 degrees. That has to be 150.
Why?
The 30 was given. 30 was given right here.
Oh, for the supplementary angle?
Yep, those, well, it's a four-sided figure here that's formed with those two radii and the tangents. So the total has to be 360, and you know the two tangents are right angles. So you have to get 180 between those other two. So we've got a total of 150 degrees around there, which makes this angle 75 degrees. Angle AHF. So here's AHF. So we're looking at this angle here.
How'd you get the 75?
Because this is 150 all the way around here. That's an inscribed angle. The vertex is on the circle, so it's half of the arc. So for angle AHF, I'm going to draw this out separate to make it simple, or simpler. This is the angle I'm looking for here. This piece, this arc is 60 degrees. That makes this arc right here is 60 degrees, is what that means. This arc over here is 70 plus 30. That's going from here to here. 70 plus 30 would be 100 degrees. So that arc's 100 degrees. Now remember, when we have two chords that intersect inside the circle, the angle formed is the average of those two arcs. So 60 plus 100 is 160, divided by 2 is 80 degrees. So this is an 80-degree angle. Because that vertex there is not at the center of the circle. If that was at the center of the circle, it would be 60. What's that?
They're straight lines.
They are straight lines.
And so if I just make a T anywhere, I should know that one side of the circle would be, one side of the triangle would be 60, and the opposite side should also be 60.
This is also 60 degrees, yes. Or not 60, 80 degrees.
But
Sorry.
see, yeah, that kind of breaks down that whole entire.
Well, the thing is because that's not, if this was at the center of the circle, the two arcs formed would be the same and they would both be equal to the angles. Since it's not at the center, as you move away from the center, one arc gets bigger and the other one gets smaller. But the average of the two arcs still gives you that angle. So both of those are 80 degrees. The circumference of the circle is an easy one to find. We know the diameter is what? 6, so that's just 6 times pi, which is 18.84. Good. That is centimeters.
1975 on ADC.
ADC, because from here to here is a 150-degree arc,
Oh,
and that is the inscribed angle, so it's half the arc. Let's look at some other pieces we can find here. Let's look at, let's see. Let's look at arc CDF here.
hold on. How did you get 30 degrees on that arc?
We're at
Go up. On CB, the CB arc.
this central angle is 30 degrees. So since that vertex is at the center of the circle, the arc is equal to the central angle. So now the arc we're looking at here, so I get rid of that without erasing it. There we go. Now the arc we're looking at is CDF. That's this arc here. Now we've actually done all the work to find how many degrees is that arc. 150. How'd you get 150?
180 minus 30.
Yeah. This is a diameter, so that would cut off half the circle, 180 degrees. We know this one's 30 degrees, so it's just 180 minus 30. So arc CDF is 150 degrees. So if we're looking for this highlighted arc, right? This is a diameter. BF is a diameter, which means the arc that it cuts here is 180 degrees. If that's 180 and this one's 30, you just subtract 180 minus 30. Leaves us with 50 for the highlighted arc here. You look confused, Josh.
Where did you get the circumference? How did you know that?
Circumference, we just had the diameter we'd figured out up here is 6. So it's just 6 times pi. Pi times diameter.
Yeah, where did you get 6 again? Because no, oh,
Because you know that the GB is 3. Next, let's have you look at arc. We've already found this one, but technically we haven't. Arc EF. So that goes from here to here. Well, we know that arc AF is 60, right? So it has to be the same. How do I know those are the same? Well, because this is a radius or a diameter and it meets that chord at a right angle. If it meets it at a right angle, remember it cuts it in half. So if it cuts the chord in half, it cuts the arc in half as well. How about the area of sector BGC? BGC. So that sector, BGC, is this sector right here. How would I find its area? Yep. We're given that the radius is 3, so the area of the whole circle is pi times 3 squared. So that's going to be 3.14 times 9 is 28.26. So then the area of that sector is the 28.26 centimeters squared times the 30 degrees over 360. Because that is a 30-degree angle in there, right here. Because it's 2.355, 2.36. Those are in centimeters, so it'd be centimeters squared is that area. So that one's reaching back into last semester a little bit. So next, angle GFK. So GFK, where is angle GFK here? Here's GFK. That's a 90-degree angle. Good. There's not a lot to do there. And even if I didn't have it marked as a right angle, you would know it has to be because it's a radius going to a tangent.
What about JDC?
JDC?
Yeah.
Okay, angle JDC. This angle right here?
Oh, 30
Yep, 105. Has to be supplementary.
What about DCH?
DCH, where are we?
Yeah.
DCG, you mean?
DCG, yeah.
Okay, so that's this angle here. Well, what we have there,
Oh, we got a median.
I'll draw it off here.
Two.
Not necessarily an altitude. I'd draw it a little bit better. We know this angle is 150. We knew this angle is 75. And we had this angle here is 80.
So 360 is
So, yep, it's a four-sided figure. So you subtract from 360, you'll get that angle. Let's see, what else do I want here? I want to find the length of IA.
Go back.
Length IA. Now you know what it's going to be like to be married. So IA is that length right there. We're told that, oops, that's not right. EA is 5, right? So what's IA have to be? 2.5. It has to be half of it.
How do you know that?
The whole thing is 5, right? Since that diameter cuts it at a right angle, you know that cuts that chord in half. When a diameter,
It's equal like that.
whenever a diameter or radius cuts a chord at a right angle, so we put a chord here. Whenever that radius hits that chord at a right angle, it cuts the chord in half. Cuts it into 2 equal pieces.
Okay, yeah.
So it does have to be 2.5. And you already kind of asked what this angle here, how would we find CJD? I'll just write it down here. Angle CJD there, how would we find it? Well, it kind of goes back to the same thing we did here. You've got 150 degrees here, 80 degrees here. This is 90 degrees. So that's a four-sided figure. That's this figure here. So it's just a matter of 360 minus 90, 150, and 80. What's it come out to be? 40? Sounds about right. Degrees. What do you think? It's all one big puzzle. The key is seeing all the pieces and putting them together. Okay, Hannah, you had some questions off the homework. What page are you looking at? Which one?
He says so many of them.
Just pick one. Pick a couple. We've got time. We got 25 minutes.
I love the honesty.
Which was that, page 307?
Hey, that's why I got a highest cumulative GPA.
What's that? 316, okay. Number 12. Okay, so page 316, number 12. So our picture looks something like this. That's given as a right angle. And the center of the circle is given here, so that does not cross at the center of the circle there. This is angle 1 right here. So what we're given in number 12, part A, we're given that angle 1 is 25 degrees. So we're told this is 25 degrees. And that arc MPT, so that's the arc from here to here, is 95 degrees. Find arc KTP. So KTP goes from here to there, right? Yeah, has to be 180 because it's the diameter of a circle. Yep, this goes through the center. Since that's the diameter, that's 180 degrees. This is the center of the circle. That's the diameter of the circle. So that means it cuts the circle in half.
How would you find it if it wasn't in the center of the circle?
For that one, there really wouldn't be anything you could do.
Okay.
I mean, there's a couple things I guess you could do.
Well, if it's not-
You also know that this is a 90-degree angle here. And that is the inscribed angle for that arc. So if that's 90 degrees, the arc is double it. Arc PT, that just goes from here to here. Well, that one has an inscribed angle of 25 degrees. That's going to be 50. Arc MP goes from here to here. Well, we have that bigger arc is 95. And we found the purple arc to be 50, so the brown one, there's just the difference. So 95 minus 50 makes that 45 degrees. Then they go back and they redo the problem given different information. So if I erase some things here. This is not 95 anymore. That red arc is still 180, so I'm just going to leave that on there. But we are told now that angle 1 is 17 degrees 30 minutes. And that MPT, that's that blue arc, is 103 degrees now. Find KTP. Well, KTP is still 180, right? Still half the circle. PT. PT goes from here to here. That's just going off that 17 degree 30 minute. Double 17 degree 30 minute is 35 degrees. arc MP. Well, that's this one again. That's going to be the 103 minus the 35. So 68 degrees. Pick another one. 16? Ooh, that one's a pretty one. Not sure if I'm going to be able to draw that one. That's close enough there, I guess. What's that? So we're given this arc is 108 degrees, 19 minutes. This here is angle 2, angle 3, and angle 1. We got A, B, C, and D. Now my points here. So for 16, we're given arc AB is 7220. So this arc here, 72 degrees, 20 minutes. Arc CD from here is 50 degrees, 18 minutes. They want you to find angle 1. This angle right here. No, not quite. Good thinking, but not quite. Arc AD here is what's left, right? Out of 360. So we have to add those up. 108.19, 72.20, and 50.18.
You need to say 108.
What? No, because this doesn't intersect that arc. It's an exterior angle. We're looking for angle 1 out
No,
here.
I mean AB.
AD is 108? No. 108 goes from here to here. So we've got to add these all up. We get 17. That's 57 minutes. 0, carry the 1, 8, 13. 230 degrees, 57 minutes. And we'll subtract that from 180. Or 180. 360 is the whole circle. So 360 degrees, 0 minutes, minus the 230, 57. So we'll borrow here to make this 359 and 60. So we've got 3 minutes and 129 degrees. So this is 129 degrees and 3 minutes. If we know that's 129 degrees, 3 minutes, this central angle is also 129 degrees and 3 minutes. And now that we know that, we know this angle is supplemental to that angle. Those two have to add up to 180. So 180 minus the 129. 129.03 should give us, what, 50.57? So 50 degrees, 57 minutes.
Go back to 12 quick.
Yep.
How'd you find PT?
PT,
Yeah.
that just goes from here to here.
Yeah.
That's your inscribed angle, just double that angle.
Hold on. No. First problem. 12. Or no.
First part A of 12?
Isn't that what we wasn't it the first question? That we did?
Yep, this is it. This is 12. Whatever this angle is, this arc here has to be double it. Let me get the rest of my crap out of the way here. Whatever,
Oh, yeah, okay.
yeah, whatever this angle is, this arc is double it.
Yep.
That's where it's kind of tough because you have to go through so many steps to get through some of these. You go back to use something you figured out before, and it's like, well, where the heck did that come from? So anyway, we got angle 1 here is 50/57 on 16. Part 2 is angle 2. Angle 2 is going to be up here. That angle, I can find very similarly. I draw in this here. I know this angle is 72 degrees, 20 minutes. So angle 2 has to be the supplement to that. So 180 minus 72.20, which is going to be 107.40. So angle 2 is 107.40. Oh, wait a second. Nope, that can't be. Never mind. That one don't work. That worked with angle 1 because these were both tangents. I got ahead of myself on angle 2. One side's a tangent, but the other side is not, so I can't do it that way, can I? What I have to do there, since that is what we call a secant, so what we're looking at is we have a circle here, and even though one of them's a tangent, it still counts. What I have to do is I have to find this arc from here to here. That's going to be from here over to here. That's going to be the 129.03 plus the 50.18, which is going to be 179.21. Okay, that's just found by adding these two arcs together. Then I have this shorter arc of 72.20 that's right here. And remember, when we have an exterior angle like that, if it was interior, we'd add the two arcs together and divide by 2. If it's exterior, we subtract them. So 179.21 minus 72.20, then we divide by 2. So we subtract those, that's going to be 107.01. Divided by 2 is going to be 53.30. Technically 30 minutes, 30 seconds. Finally, anybody have any questions on that one? I know that one's kind of a tough one. That was a rule we haven't used yet, is where we have to do the secant angle like that. Angle 3 now is going to work the exact same way. Angle 3 over here find that angle, I have to have this arc and this arc. This arc is given as 50.18. This arc over here I've got to find by adding together 72.20 and 129.03. So that's 201.23. So again, we're going to follow that same formula. $201.23 minus the 50.18 divided by 2. 201.23 minus 50.18 is 151.05. Divided by 2 is 75. 32 and 30.
So on those, when you have the minutes and seconds,
Yep.
remember how I rounded?
If you rounded that to 75.33, that'd be okay.
But when I rounded, what did I? When you get a decimal, you're supposed to time that decimal by 60, and that'll be your seconds.
Yep. Yeah, so this would technically divide out. You'd have the. What you'd do is this. So if you're dividing that by 2, right? What's going to happen is, I'm going to slide this down a little bit. You would divide 151 by 2 is going to give you 75.5. You put up the 75 here. Then you subtract the 75 off here. Then you got to convert that 0.5 into minutes. So times 60 makes it 30 minutes. Add the 5 that's already here, because you already got 5 minutes there. So I'm going to add that 5. So we're at 35 minutes. We're still dividing by 2, so you divide by 2 again. So it's going to be 17.5. Again, I write down the 17. Take off the 17. Multiply by 60 to turn it into seconds. So I have 30 seconds. Now there's no other seconds over here. So that's just 30 seconds. The calculator.
Yeah, but there was,
Yeah.
there was some way that I couldn't do that on the test. In the quiz that we had.
You could. There was something, you might have been entering something wrong. What calculator do you have?
I got the
TI-30?
Texas Instruments.
So on yours, you have a key up there that looks like
Yeah,
this.
the circle, the minutes.
Yep, degrees, minutes, seconds. So you should be able to enter 151, hit
It
that
was
key.
one of those things where it was one of the questions where you said transfer it over to
Yeah, decimal degrees to degrees, minutes, seconds.
Yeah.
Yeah, you must have entered something wrong on it.
Well,
Because it should
so
do
it
it.
was 70, so it was 75.5 and change
Yep.
that to degrees.
So on your calculator, you'd type in the 75.5, right?
Okay.
Then you would press this key and it'll bring up a menu.
Yeah.
The menu will look like this.
Yeah.
You have to arrow over because if you arrow off the screen, there'll be a DMS.
Okay.
Select DMS and you have to hit enter twice.
You have to enter them separately.
Okay.
What's that?
You
Okay.
have to enter them separate.
No, you just do 75.5 as a decimal.
I didn't know that. I didn't see that DMS.
Okay.
Okay.
The good news is there is no new homework today. The bad news is I'm going to be sending a quiz home with you that's on these circle stuff. I send this one home because it's just one of those that takes a while to figure it out. I'm also going to give you, so making sure it's not in this packet. Actually, it is in this packet. In this packet, starting on page 319 in the packet, it talks about the fundamentals of geometric construction. I'm not going to assign this. It's not going to be on the test. If it were on the test, it would be an extra credit question for you. And what this is this is stuff that if you were to go to the next level and become a CAD operator and do some drafting and stuff like that, you would need to know how to do this. You don't draft it out by hand using a compass and a straight edge anymore, but it's the same principles you would use to do the constructions using a drafting program. So it's something that I put out there. It is part of the course, but since we modified it to be a CNC operator and not a 2-year machine tool program anymore, this is not as important as it used to be. So I offer it up just as something extra you can do. So starting, like I said, on page 319, you can go up through there. It talks about some different geometric constructions. It actually goes all the way up through the end of the packet, I believe. Up to page 328. So for those of you that are interested, it's something you can read through. This is officially the end of Unit 3 here. So on Monday, we will have our Unit 3 test. So that test will be Monday, and then we'll be starting then into the actual trig stuff next week.